Time. I'm your host, Dr. Matthew Richardson, and welcome to another stream of CosmoQuest Astro Office Hours. Um, Give me a quick moment, guys. I'm gonna quickly open up a Chrome browser and see if everything's going okay with the stream. But I hope everyone's doing well today. Let's see. All right, it's still showing offline, but I'm pretty sure it's going. At least I hope it's going. All right, yeah, it's up. It's up and running. But let's go ahead and gain access to the chat. That way I can communicate with you guys. That's weird. Still no access to the chat. This is. I remember last stream there was issues with the chat. Hopefully those issues have been resolved. Let's try this one more time. There we go. All right. Let's give it a quick test. Hey, Larry. All right. So now that I know that I can see your chat and you can see mine, the initial plan was to come on today and finish up the problem we started a few streams ago. That is deriving Newton's gravitation, law of gravitation from general relativity. But I need to get some work done. So I'm actually going to make this kind of a work stream. But we will be finishing up that problem. I have every intention to finish it. More than likely, it will just have to be pushed back until Friday, the Friday stream. So for those of you who came here looking forward to the to all the math that we were doing with Christoffel symbols and stuff like that, I'm sorry. We will continue that, but on Friday. You know what? I've had some volume issues as well in the past. Every time I would start a stream, and all right, we'll see you later, Larry. Every time I would start a stream, I would have my laptop connected to my Bluetooth, and yeah. Oh, new speakers, great. All right, so plan for today: plots. I'm trying to create one particular plot. Yeah, I definitely want to get some new tech for myself as well. Hopefully, sometime in the near future, I'll be able to buy something. All right, so my plan for today is to create a few plots. Oh, well, I'm happy to hear you got new speakers. Sorry to hear about your old speakers. But I guess that's what happens, right? Eventually things, break down. You gotta replace them. But yeah, I want to make this plot where I can see, or basically the overall objective of the plot would be to show me exactly how long does it take on average for 15 users to annotate a, annotate images from a single project. And when I initially started this writing the code for this, I figured I'd be able to get it done in like a day's worth of time, but then I ran into some problems, which typically happens when you're coding. And so I had to kind of take a different approach. Yeah, make sure you protect the new one, definitely. Okay, so the very last time I ran this, it compiled and it was able to actually do, or it was able to handle the modifications I've made to it. So initially, when I started making this code to do it to create this plot, hey Michael, initially when I start writing this code to create this plot that I was just talking about, the plot being able to determine on average how long does it take for 15 users to annotate images from a single project. I ran into some memory issues. It kept saying that I was seg faulting, and I was like, I can't be accessing memory that I don't have access to, because I've made sure of that. But well, apparently, I was requesting too much. So in C++, there is the vector class, and whenever I use the vector class, there's a particular function called the pushback function for for vector, and it allows you to dynamically allocate memory for you know elements. Well, apparently I was just requesting too much memory. My vector got too large, and the computer was saying, no, can't go any further. So now I've had to kind of modify the program to kind of do things a little bit differently, but get the same result ultimately. Okay. But yeah, Michael, I started off by stating that today I will not be finishing up the problem we started a few streams ago. I will be coming back to it, but on Friday. Today I'm just going to be focusing on getting these plots out. Let's see. Vector so that's the first something. That's good. Determining lifetime for the first 15 people to annotate image. So I'm doing time diffs. I think I need to actually create this particular vector. Let's just create it out here actually. Make it easier. Oh wait, it's already created. So this vector right here, completion elapsed time, essentially what the plot will show is as a function of image. So along the x-axis, every single tick essentially would correspond to a single image. And along the y-axis, that happens to me sometimes too, with the whole username issue. Well, more so with the password. I generally try to make sure that I, maintain a very common password. That is, I'm not like going all over the place because when I was in grad school, we had to regularly change our passwords to our accounts, and you couldn't use the same or very similar password. So I had to come up with a way of creating new passwords that I could remember, but weren't extremely different to the point where I would forget them. But yeah, I typically just use the same username if I can. Ah, okay. That's probably the best way to do it then. Let's see, completion elapsed time. Right. So the plot that I'm trying to make right now. So along the x-axis will be, let's just say, image ID. So along the x-axis is image ID, where each ID corresponds to a single image that could be associated with a single project. So I'm looking at all the images across a single project. For example, let's take, for example, the Moon Mapper project. X-axis would hold all the image IDs for the Moon Mapper project. And along the y-axis, I basically would have the elapsed time taken for the first 15 people to annotate a particular image. And so with that information, I can basically just take what I would want to do then is I would want to take an average, um, I guess an average of the function that's generated from that plot. And that would allow me to know the average amount of time required to average amount of time required for 15 people to annotate images that are associated with a single project. So that's what I'm doing right now. And so the completion elapsed time vector is basically going to hold all the information for the y-axis. Hey, Susie. But you know what? I'm going to try to make this stream a little bit more interesting beyond what I'm talking about here. So of course, my day job is being an astronomer, physicist, whatever you want to call me, a scientist in general. And so I also like to work on cars. So so that's actually a good question, actually. So based off of a past study, if I'm remembering this correctly, it takes at minimum 15 people, or taking the annotations that have been produced by 15 random people, actually, um, will should be good enough to produce results that are comparable to, for example, if we had a professional crater marker marking or annotating our images. The reason why I'm taking the first 15 people is because I just want to know, well, how long does it take just to get 15 people? And I mean, even though some of the projects show that, or some of the images show that we've actually had more than 15 people annotate that particular image, at minimum, we're saying that we just need 15 people. The first 15 will do. And that the first 15 people should be able to generate annotations that are comparable to the abilities of a professional crater marker. And so if I were to choose, for example, I guess I could choose any 15 people, any 15 consecutive markers or annotators, and to see what's the elapsed time there. That's possible. Who's Nightbot? Is that like a non-person that's doing this? Oh, I see. I see what you're saying, Michael. Let's see. I can erase this. Okay. Thanks, Susie. For a second there, I was like, I don't remember a Nightbot ever ever showing up to the stream. I was getting ready to say hi for a second there, but I was like, wait a second, that isn't the message that it sent out was kind of weird. Well, to kind of be fair to everyone, hi Nightbot, welcome to today's stream. Let's see. So completion elapsed time. This is good. It's gonna push back by the time difference. But yeah, I guess it's just. I think it's what you said earlier, actually, Michael. I think it's just easiest to choose the first 15 people versus choosing a random set of consecutive annotators that total in 15 people. Yeah, the key thing would be that they'd have to be their timestamps would have to be in such a way that they're consecutive markers. But yeah, I was saying earlier that I like to work on cars, and so lately I've been working on my 1998 Oldsmobile 88. It's the first car that I ever bought, and it's quite literally gotten me everywhere. I've had it since, what is that, 2008? And so I've been working on it. I just did a complete rebuild of the engine, and I'm happy with the results so far. So if this whole physics thing doesn't work out for me, I'm going to try to see if I can become a mechanic. Just playing. Let's see. All right. So use your timestamps. If there's greater than or equal to 15 people, record the elapsed time. Otherwise, just put it at 0. Okay. And so now I need to plot this. And so I typically keep all of my plotting algorithms all together in a single file. Let's make that, oops, make that bigger again. So what do I want to call this one? Ice cream. Ice cream. Oh man. Oh man. It seems that every single stream we have, someone brings up food. And I have to keep remembering, I know they were across different time zones, but this is lunchtime for me, and food sounds really good right now. Really, really good right now. Let's see, current users, marks per user. What did I want to call this? Average. Let's see, average. Let's put it up here. Average image completion time. And I need to pass to this some vectors. Let's make them both double vectors and make this simple on myself. So double and one more. And basically these vectors that I'm going to pass to the function are going to be the x and y axes. Oops, there's some sound issues there? Or is it just the way I'm talking? That should be good. So let's go ahead and define it. Make this simple on myself. X-axis, Y-axis. And much of the stuff I'm doing right now, I could just simply copy and paste what I've done before with other plotting packages. Except this time I'm not making a histogram. This will actually be a scatter plot, so. I don't need these labels. This is not going to be a histogram, so I'll use t-graph, which would correspond to a type TG, or t-graph, excuse me. And so I'll name this TG. Don't need bins because, again, this is not a histogram. And then this whole x high, x low thing, I don't need neither. All right, so far so good. Canvas is initialized. I mean, I've been known this. I haven't just realized, but I've been known that If I didn't make my code look so, try to make it look so pretty, this would go so much faster. Let's see. So T graph equals new T graph. And let's see. It's been a while since I've actually used a T graph. I think it requires 2 strings for the first 2 arguments, and then I think I can actually specify what the x and y vectors are. I think the x-axis goes first, but because of this is a vector type, I need to actually pass something that's similar to like the normal C array. So I think it's x-axis dot data. I'll have to look that up again. And this is going to be y-axis. Let me take a quick moment to actually make sure that that is the correct function. Vector function, let's see. C++. You guys can't see what I'm doing right now. I'm basically going online and I am looking up the vector class to see what some of its functions are. Oh, this is taking way too long. Just to open up this one web page. And given that it's taking so long, let me look at my connection and make sure that it's stable. I got a green light, which means that there shouldn't be any issues with the stream, hopefully. All right. So it is the data. Yes, data is right. Just to make sure. All right, so that should be this. That's good. And now I can plot it. And for now, I'm just going to do something as simple as take my graph variable and just simply draw it. And make sure to draw the axis. For now, we'll use stars as the data point, or asterisks as the data points. And draw a line between them as well. So AL star. All right, and then lastly, I can save it. For this, I'll just simply copy and paste something else. And also always free the memory that I've requested for the plot. What should I call this? No names coming to no particular names coming to mind right now, even though it should. Elapsed or average completion time. That works. And then this can be that. Okay. Let's go to Bash and let's try to compile it and see what happens. Ouch. Okay, let's see. A lot of errors. Then a few warnings. Oh, hmm. Do I not have this class already included? That's what I forgot. So I have to include the class. Yeah, this is the first graph I've actually made for this particular. I've used this plotting package before with other things, but this is the first time I've actually had to use it for this like analysis. All right, T graph, it's there. Save it. It's clear. Let's do it again. Okay. Let's see what we got here. So, oh, I didn't choose a proper constructor. Okay. So that's why I made the mistake. All right, so that's easy to fix. So the problem it's telling me is that basically I've supplied the wrong type of arguments to the T-graph constructor. So I can reduce this by basically just indicating what is the number of elements within the vectors. They should have the same number of elements. So what I'm going to do is I'm just going to make a new integer variable n, and n is going to be equal to the size or the number of elements in the x-axis vector. Let's put in here. And that should fix things. Let's clear it. Let's rerun it. And it compiles. All right. So let me now take a look at this plot. Well, before I even do that, I need to go back to my utilities class and actually use the new function I just made. So let's see. Update index. So plot data. And let me actually look at the comments. It's been a while since I've looked at the comments. Let's see what's going on here. So wait a second. You're gonna drink tea and not alcohol. I love tea. Tea's great. Hello, hiptacular. Okay, I'm saying that so wrong. I see a raptor in there. Hiptacula raptor. Welcome to today's stream. That's a new name, actually. I believe this is the first time I've ever seen your name here. Hey, Uncle Bill Druin. Yeah, guys, I am not. So yeah, for those of you who just joined, if you came looking for us to be talking about general relativity, we're not doing it today. We'll be doing it this Friday. I'll be resuming. Well, I'll be resuming and ending the problem that we started. But today I need to get some work done. All right, so I need to plot this. So right now I'm trying to produce a plot, and ultimately the plot should allow me to be able to determine how long it takes for the first 15 people, in this case, the first 15 people, to first 15 people that are annotating a particular image associated with a single project, how long it takes for those first 15 people, on average, to do their annotations. Or I said that wrong actually. It's how long it takes for this 15 people period to annotate a single image associated with a single project. Let's see. Plot data, and this is going to be plot. What was the name of that function again? A very long function name. Oh, really? Oh, man. Now I kind of wish I really was actually doing the GR problem. Yeah, today is not going to be as fun as it typically is. In the last stream, we were attempting to attempting to what's up with my words right now? We were attempting to what is the word I'm looking for? Derive. There we go. We were trying to derive Newton's law of gravitation from general relativity. And the plan was to finish that problem today, but I decided it would be best if I get some work done. So that's currently what I'm doing. And also, yeah, I almost really forgot. I should note this, guys, that the primary reason why I'm doing this is because we really want one for more people. Nothing's wrong with the numbers we're getting right now, but we'd want for more people to visit CosmoQuest and annotate our images. What's up, Big J? Let's see. I need to put the vectors in here. But I don't have the x-axis vector yet. That sounds like fun. Grading papers. I don't miss it. I do not miss it at all. And when you're in your case grading projects. I just realized that I haven't even defined the x-axis. In this situation, I think it might just be easiest if I just make a vector that just has integer values that aren't actually equal to the image IDs. Because it's gonna make the plot look really weird if I do it that way, using the image IDs for the x-axis. So let's do this. Where do I define? Or not define, but where do I determine the image ID? Somewhere in here. Here. So what I'll do is I'll make another vector. And I'll call this vector x-axis. Vector of doubles. That'll work. And this is just for the time being, so I can see the plot. And so every time I actually record the image ID, what I'll do with x-axis is I'll record a single integer value. Or is it the best thing to do? Let's have a counter as well. So I'll increase the counter. And I'll push back by the counter. Not C3PO projects. Ah. Oh, that's interesting. So these projects can be written in any language, and it's your job to be able to understand it without even probably even knowing the language. That's interesting. Let's see, that should do it. Yeah, I still need to learn. I still need to learn Python. I've quite literally written like probably like a line of code in Python, and that was a part of me initially trying to learn Python. So, and then I stopped. I have to get back to it. Plus plus x-axis. This should be good, I think. So it's the image ID. Hmm. All right, so what I need to do now is make sure that the number of elements in x-axis will be equal to the number of elements in completion elapsed time. I'm kind of concerned about that. And right now we'll exit there. And hopefully this compiles just fine. Should. I don't mind warnings. Warnings are okay. I typically end up fixing those eventually anyway. Let's see, that's good. Okay, so / analysis tools. So given that I'm using more resources on my computer than I typically use when running these codes, um, it's going to take longer for it to actually complete the program. And so typically around this point of the program, it takes about 16 seconds because I'm grabbing information from a copy of CosmoQuest's MySQL database, but I'm pretty sure it's going to take a lot longer. Could almost be up to a minute, actually. Let's check the comments really quick. If you can code in C, you can almost code in anything, huh? Funny thing about it, yeah, I started off coding in IDL, and I've forgotten most of the syntax for IDL, but I'm pretty sure if I were to see some code in IDL, I probably could still remember it slightly, or at the very least, quickly be able to determine what it's doing. All right, that's perfect. They have the exact same number of elements, so that means I should be able to plot it and see what happens. Okay, let's see what I get. So plot. Let's make sure that it's going to it should do it. So as of right now, I should be able to see a plot that will help me understand what the average amount of time that elapses for 15 people to annotate a single image for the Moon Mapper app. So I'm going to recompile this and I'm going to run it and see what I get. If what I get looks nice, I'll show you guys. If what I get looks completely like outrageous, I'm not going to show you. And I'm going to try to figure out what's wrong. Let's see. All right. It did take almost a minute. So what I've noticed is that every time I'm doing these I'm running my programs with the stream running, it takes almost about 4 times as long for it to complete the entire algorithm. And that's taken some time. 24 seconds. Okay. Let me look at this plot. Hopefully I'm happy with it. I got a few more plots to make. Let's see. Analysis. Oh, that's not it. This is so average completion time. Let's see what we got. It seems everything's taking longer. Even opening up this PostScript file is taking a long time. Oh yeah, Big J. I was meaning to ask you. Did things go well with your car? Okay. This graph looks horrible. Huh. Right. Okay. So there's actually a lot of gaps in my plot here, and the gaps are due to the fact that some of the data is being um, is being rejected because it's not a part of the Moon Mapper app. So what I should do is modify. Okay, I know what to do. So the graph actually looks good, but it just looks bad right now because of the fact that there's all those gaps. Oh my god. Oh. I'm sorry. I'm laughing at what Peter just stated. Oh. Okay, you were just getting bad fuel. Yeah, before I made some modifications to my car, there was a lot of a white what was it, white smoke that was coming out of the exhaust pipe. Initially I thought that it was coolant getting in the engine oil. It turns out that one of my fuel injectors was like it was in the stuck open position, or it was broken essentially, and it just turned out all I had to do was fix that. But I ended up doing a lot more though. Nevertheless, I'm happy with what I've done so far. All right, so let me go back to the program. And what I'm going to do now is I'm going to remove. Let's see. I'm only going to actually record non-zero elapsed times. So what's another way of doing this? So what I can do is this. I can get rid of this. And now what I can say is something along. Yeah, I didn't show the. I'll show the graph actually. I'll show it. Just give me a second. I didn't show it because it came out looking really weird. And right now I'm trying to fix the weirdness in the plot. But give me a second. I'm going to go ahead and show it though. Average completion time. As soon as it opens. While it does that though, I can at the very least add another. So plot. And this is preview. It's still loading up, guys. But you'll see that it looks extremely weird. Let's see. Video capture. But for the most part, it looks like it's doing what it should do. Nevertheless, it looks horrible. It'll look better once I remove the valleys. But once it actually loads up and you can see it, you'll see what I mean. Any minute now, it'll finish loading up. This is taking so long. I'm more than sure that it's taking this long because I'm trying to do this while also streaming. Which is the reason why I need to get a workstation that kind of like matches Big J's. Oh, no problem, Michael. I'm hopefully it shows before 1 o'clock. And this is taking forever. This is so weird. It's never taken this long. There we go. So this is the plot. And as you can see, there's like there's moments where there's like spikes, and then there's a lot of like drop offs to zero. And I must note that along the x-axis, you can imagine that's going to be the image ID, and along the y-axis, we basically have the elapsed time that it took for the first 15 people to wow, is that right? But yeah, it's the elapsed time it took for 15 people to annotate a single image. That can't be right. No, that can't be right. It's in units of seconds along the y-axis. And if I'm saying this correctly, so 180 million seconds. What is that? Isn't that one? That's 1.8 times 10 to the 8 seconds. There's pi times 10 to the 7 seconds in a year. No. That doesn't make sense. It took for some of these projects. It's taken more than a year. And I shouldn't use one. I should use 1.6. But I mean, nevertheless, 1.6 times 10 to the 8 seconds. That's more than a year. Just for 15 people. The first 15 people. That's insane. I'm gonna convert the y-axis, which is the time axis. The y-axis is the time axis. I'm gonna convert it to units of probably months or years or something like that. But right now it's in units of seconds. I'm gonna double check some of this, but I mean I have to double check it anyway. But it seems kind of weird that it takes that long for 15 people to annotate a single image. I think this might be a good question to kind of ask like Tanner or Corey, because that seems abnormally a long time. So yeah, I could definitely what I'm going to do what I'm going to do first is I'm going to remove all the images that have essentially a time difference of zero. That's the first thing I'll do. which will get rid of the gaps. Another thing that I'm going to do is I'm going to remove the lines. So there's basically lines going from each data point. So I'm going to remove the lines. I'm going to change the data point because that's fairly, I think it's too big. And also I'm going to change the units along the y-axis. But you're also suggesting that I do, let's see, what was that? And so yeah, I can definitely remove results greater than a few days. Oh yeah, I'm definitely so yeah, Big J. I'm definitely going to just get rid of. I'm going to get rid of all the data points that are equal to 0. That way, I remove all the gaps and everything. So everything that comes after 22K along the x-axis, yeah, I'm going to get rid of all of that. Yeah, this is just this is the first graph. I mean, I typically I almost always get graphs like this, and then I have to like make modifications to make it look nice and actually readable. You see gas from Uranus? But yeah, this is a horrible looking plot right now. Too much white space, amongst other things. Well, guys, thank you so much for like joining me today. I know that some of you guys came looking forward to talk a little bit about some GR stuff, but we will continue this Friday. But I want to get these plots done first. All right, guys. That's my time. I'm going to go ahead and log off now, but I'll be back Friday afternoon at 12 o'clock p.m. Central. And so I'll see you then. All right, guys. Thanks. Bye.